previous videos, we talked about additional layer of coating for additional protections to the strain gauge. This includes the N1 coating, SB tab, and VM tab. Now let us look at the applications of N1 coating. N1 coating is an air drying rubber solvent adhesive that can be used as single layer coating for indoor experiments. First, you need to prepare the material. This includes the N1 coating, the brush, and also the masking tape. Next, you prepare the surface. Clean an area of the test specimen surface. The area will need to be slightly larger than the area to be coated, and then you apply the N1 coating. Apply a layer of N1 coating material with a brush so that the material covers the strain gauge. It should also cover the connecting terminal and also the underside of the lead wire, as well as the adhesive around the gauge base. This goes back to the principles of the applicable area for the coating. The coating should not only apply onto the strain gauge only, as moisture can still leak into the strain gauge to various ways, such as from the lead wire or from the adhesive underneath the gauge base. You need to pay attention on the underside of the lead wire in order to ensure that it is fully covered with the coating materials. Apply the N1 coating sufficiently thick to cover the strain gauge as well as the lead wire. Next, it will be the hardening of N1 coating. The adhesive dries as the solvent vaporizes, forming a rubber coating. After the adhesive dries and hardens, if the coating is too thin, you may apply another layer. This goes back to our principles of applying the coating, that applying multi-thin layers of coating is better than a single thick layer of coating. Therefore, you may apply an additional layer of coating using this N1 coating. Now it takes about 6 hours to completely vaporize so that the coating is hardened. Now the hardening process is based on vaporizations of the adhesive. The hardening process may delay under a sealed environment, or if adhesive layer is very thick, this will slow down the vaporization process and N1 coating will harden slowly. You should wait at least 24 hours before taking any measurements. Now, if you look at the functions of the coating that you use, N1 coating is used to protect strain gauge against the moisture or water. Same goes to W1. Both are having the same function. You may choose either one to protect the strain gauge from moisture, or you may use both, which personally I feel is not necessary. Since N1 coating and W1 coating are having the same function, and if you look at the procedures of applying W1 coating, it is more tedious as it involves heating of W1 coating. Wait until it liquefies before you can apply onto the strain gauge. In comparison, the N1 coatings is simpler. If you wish to make your work to be simpler, probably N1 coating is a better option to you. You may apply several layers of N1 coating onto the strain gauge in order to ensure full protections against the moisture. The only thing that is, you need to wait at least 24 hours before you can test the specimen. Now if you are concerned and take a more conservative measures, you may have an additional layer either by using the SP tab or VM tab. These two types of the tab not only provide resistance to moisture and water, it is also easy to use. Now let us talk about the applications of SP tab coating. The procedures is similar to VM tab. Now both SP and VM tabs are pressure sensitive adhesive tab. They are applied simply by pressing them onto the coating area. Let us look into the procedures of applying this tab. First, prepare the material. This includes the SP tab, scissors, finger cords, and spatula. Like always, you need to prepare the surface. Clean the area of the test specimen surface. The clean area should be slightly larger than what is intended to be. Apply with SP tab. Then use the scissor, cut off one piece of the tab larger enough to cover the coating area. This one is to be applied onto the strain gauge as well as the coating area. You will need another piece of SP tab, which is about 5 to 10 mm in length, to fit under the lead wires. Next, lift up the lead wire and press a smaller piece of the tab onto the test specimen under the lead wire, and then the larger piece of the SP tab should be laid on top of the coating areas. Why do you need a piece of SP tab to be underneath the lead wire? This goes back to our principles of securing the lead wire in order to prevent the moisture leaks through the lead wire. Press the SP tab against the coated area, and now the coating is completed. Now, in order to ensure there are no gaps, make sure you press the tab down firmly with a spatula or with your finger, covered with the separating papers for the roll of SP tab. Make sure you do not handle the SP tab with bare hands, as the oil and other soiling on your finger may contaminate the tab. This may lead to impurity underneath the tab, and this defeats the purpose of using the tab to protect the strain gauge from impurities. Now, if you need mechanical protections, probably additional coating shall be applied. You may use this P2 adhesive together with the bandage to provide mechanical protections to the strain gauge. These mechanical protections may be laid after the SP tab.